Welcome. I am Juanmi Taboada. I'm going to show you my drive away about building a submarine through something that took me almost 4 years, including pandemic time, and this is the final result of it. First thing that you need to decide to make a submarine, you need passion for the water. You have to like water. You have to start being curious about it, and getting, when you get there first time, you are totally lost. It's like everything color is blue. For everybody, most of you maybe haven't done scuba diving before, so the first experience when you get first time to the water is a test of 30 minutes, and you discover many new things. Like you cannot stand in the water, stay in the water for a very long time. There is a limit of 1 hour and a half, maybe 2 hours maximum. It depends on the depth that you are diving. But definitely, most of the interesting things that are happening in the water, in the sea, is in the first 20 meters, not deeper. Why? Because the light is moving into the water, and it's like plants. The life or the nice fishes that you can see, most of them are all around the places where the sun can get there. So around 15 meters, 20 meters is almost everything sand, and the life is different, of course, and you can find even deeper life, but most of the life is on the top of the water. So with a basic scuba diving license, you can get to these 20 meters. You can last from 45 minutes until maybe 90 minutes, and you can have the experience of it. When you go to the water, first time in a new place, you have to make a plan. You just don't get to the water without knowing anything, so you have to study this place. My first experience was that it's terrifying to think that you are lost, because when you get there, everything is blue. Around 10 meters, when you look up, down, everything is blue. Everywhere can be blue in a specific moment. So it's a good idea to take a plan. I would like to have a map, but there are not many. So when I started this project, I decided to get into this project because of that, to make a 3D map, like a kind of Google Maps from under the water, only from coasts. So when you are going to scuba dive first time in a place, you are able to plan your trip, and you will know if you will see how deep you must stay to see something, how are the caves, and things like that. Again, this is it. If you are diving, this is the image that you get. It's everything blue, okay? So another thing that you need to make a submarine is passion for software, passion for computers. And I have that from very early. When I started university, it was like a sparking thing. No? It came to my life, and I started doing many new things. Most of them happened in this environment, the environment that you are having here right now, in open source communities, especially in Linux Malaga, which I joined in 1999. And we became like good friends and a group of experiments. Most of my friends are here today, and they are sharing information, the knowledge that we have been earning from 1999 until now, and building software that you all have probably in your phone, some, but most of the people that you have Android, you are using already open source software. Another thing that you need is passion for researching and learning. It's something basic in the open source communities. You have to look, you will face difficult situations where you are not able to go forward because there is no knowledge. You look around, you ask to everybody, and nobody knows anything that can help you to resolve your situation. The submarine is here because of my resilience on this, my knowledge, my experience on all the story, learn on open source communities that sometimes you just have to feel alone and be alone and just keep trying. Also, you have to have the passion for sharing. In 2003, I was part of Malaga Wireless. We have been here in La Térmica, that's La Térmica, Sala Benalmádena, from the year 2003. You have to have that. You have to share. You are in a community, you are getting something, and you must give something back. So what is it? The basic plan is to make that's it. I want to make a 3D map of the place that I want to go. What you can do is just to scan. You can scan structures, save in the database for later analysis, and building slowly a 3D map. You can go to do it with sonars, which actually needs a lot of energy. So for this kind of submarine, I decided to make it in some way that is low, it uses really few energy. So it's built everything with microcontrollers. There is no Linux, it's just a microcontroller compiled, it's a ASP32 and Raspberry Pi Pico, which is a microcontroller, is not a computer like we used to, without operating system. And one of the approach that I decided is to use Fecha finders. Fecha finders, they work really nice. They're cheap, but you have to modify them in somehow so you can grab the information. The information that they getting from the ground and from the fishes, you have to tweak it, change it, make it work on it. So it was a difficult approach. Then I faced Mushroom. Mushroom is an open source software for making photograph analysis, and it does exactly photogrammetry. Photogrammetry is you take many photos of one object, and you can build a 3D structure from it. So we actually have done, which is here, and we have done, it depends on internet today. I will show you now what is some recordings of a submarine and the result after doing the analysis with the Mushroom software after some post-processing. So you are seeing something that is under the water. Actually, this is entry to a different place that was requested. And in the next one, you will see the 3D reproduction of it. That's actually is Blender, it's not a Mushroom. You can take in Mushroom, you take the 3D shape, and you apply the textures in Blender. So that will be it. This is another different one, which I made the reconstruction. I brought it to Blender, and I remade it a little bit, so we could give the final client could imagine what's going on under the water, not only because of the video, but also because of the dimensions. So he would work, he would rotate it and get ideas of it. And this is the 3D reconstruction of it. That's after Blender, using the mix of results from Mushroom together with to fix it all together. Okay, a little bit of theory. Everything what you do with this stuff, you have to know a little bit of theory of how the water works. So there is a first law of the law of Archimedes law. We are going to talk about two laws. Archimedes law is the first one, and it says that any object that gets to the water, it displays, it takes out from that place the volume of that object. So if we take all that water, when we put the football ball inside the water, it displays in some water and it's going out. Let's imagine that we take it to the glass. We can measure its weight. We know how much is its weight. So the law says that the weight of that water is the force that is pushing the object out of the water. Okay? So what can happen? If the ball, we get that quantity of water and it's 1 kilo, but the ball that is doesn't weigh 1 kilo, it will float. But if we make an iron ball, it will sink because it will be more heavy than the water that is displacing, is taking out. There is another law, which is Boyle-Marriott, that says that in constant temperature, the volume of the gas, the volume of a gas mass is inversely proportional to its pressure. What does mean that? Let's see it. If we have imagine that we have this gas and it's 5 green points. When we can compress it, we reduce the volume and increase the pressure. If we do it again, it will increase again the pressure and divide again the volume. So this is happening in the natural way under the water. You are in a zero pressure, and when you are going deeper, the pressure is increasing. increasing. So when the pressure increases, what happened with the volume? It reduces. And together, when you go together with Archimedes' law, what happens if you reduce the volume? You displace less water. Yes? So it won't be so easy to come back because the volume of your object reduces. So this is what happens in this kind of robots, because somebody could say, okay, I have seen the Lego one. Yes, it is easy to build it, but it can after some depth, it cannot come back because the weight. As you see, it's changing its shape, it changes its volume, and it doesn't float anymore. So the engines cannot take it back. This is one approach. This is another one, which actually works very nice, but when you see the videos, it's working on rivers and maybe 1-2 meters of water. This one is working with the syringe, the one that we use for injections. So it happens the same. It works because it's taking inside the cap, it's getting inside water and taking it outside. But what happens when you are very deep? The pressure is very high, so you need a bigger engine to take it, a bigger pump to take it out. That means more energy. That means a bigger strength. Just for you to know, in the Boyle laws, in the first 10 meters, when you get under the water, the first 10 meters, you reduce the volume in the half. So you just can, what I said in the beginning, that most of the life happens in the first 20. So you have to count with that. You cannot forget about that at any time. Okay, we're all set with theory. What is the submarine about? My idea was that most of the ROVs that I have seen, they work with a cable, and they are together. They are connected. The ROV is connected to the chip straight. So when you are operating the ROV, the information is going through a cable, so you need to be there. My idea was a little bit different. I decided to make this one, what I call buoy, that is on the top of the line of the water. So it's communicating the top of the line of the water with the submarine. So the submarine can operate, and the buoy can retransmit all the information to somewhere else. It can be a ship, it can be the coast. What happened with this project? I decided that is to analyze the coast. So it will be connected, it will be coverage. It's using the cellular network to send information. So when I started on, it's connecting to the server, sending information about where it's located in the internet, and it gets open the port, and it allows some software to connect to it. And through this antenna, it's retransmitting the video. How is it doing it? How is doing it? It is using the circuit from a drone. Everybody has seen a drone flying. So the circuit of a drone is what is behind this antenna. The only thing I needed to do especially for it to work, it was to cool it. Why? Because if the drone is in the air, and the air is flowing and is staying cool, but in the water on the surface, it's just getting hot. So I decided to make a circulation system, so it's getting water, cold water from the sea, making it through the system that's getting hot, and putting it back to already warm to the water. And this is the way that it works. So what I was looking, something that I can share with people, the maps, the circuits, and they can make it themselves. Something that is open source, including the software. Something that is low cost, so everybody can build it. I have used only Amazon and AliExpress to get this. So it's on your hand. Low consumption, because I decided to use microcontrollers, and that was actually a pursuit. I wanted to learn on that. There was no reason to not to use a computer. There are great computers at this moment in the market. I wanted to have a fluid communication with the ROV. So, for example, I couldn't transmit the video through the cable because the protocols. We are talking about microcontrollers. They have enough power to move, enough quality of the video. Also, I needed real-time telemetry and positioning, because when you are under the water, I already said that everything may be blue. So when you are looking around, you have to know you're looking, you are going to hit the floor. So you don't want to land on some strange position, because that can give you some problems. What else? And the water cooling system, which I already talked. Come on, I'm a computer engineer, so I'm getting this information, and I have so much information from this system, so why not to save it? So I'm getting this information and saving it in the database, so I can get also to know how the ROV is performing on real time and have a history of it. Information about temperature of the water, depending where is it, I can move it around, and I will know the temperature, I will know the pressure. I'm working, especially needed to know when you are depth. I have it here, but there is a water analysis board that I also work on it, and it's supposed to make analysis of the water in different layers of the sea and so on. So what you see is another software that I learned in all this story is ground control. It's also a free software that you can use, and is using a protocol named Maplink. That was one of my biggest problems to get this project finished, because I didn't know anything about Maplink. It's a new protocol, and there were 2 versions, and I didn't know which one to use, and you had to learn, because actually this way of working, it's push you to you are working with bytes after bytes. The communication protocol is as 485. So everything what is coming can fail, the transport can fail. So you have to process each byte one after another and find out when you have the full package. So that was Maplink, and together with Maplink, I got ground control. Ground control gave me sending in the right packages, I can say where it is the ROV, what is the telemetry, and the position, and everything. Something else. Those are the SkyDroid. SkyDroid is another hardware which it helped me a lot. SkyDroid is a hardware that is used for the drones, so you can convert the signal that is coming from the drone, the antenna, to USB. So you can plug it to the phone, like I did in my Googles, and you can plug it to the computer like this one. This is plugged, and it's bringing the signal here. So SkyDroid is giving me that. What else? Micro mini OSD. This is a little board that is giving the OSD. So you can, if there is a firmware, you make it on your computer, you set some parameters, you have to communicate with it, you have send in TTL communication, you have to send the right packages, and the OS board you are managing, and you can manage all the telemetry information. So everything what you see in the screen is being sent by the ROV itself. So everything, all the image itself is being built under the water in real time. So in this way, the image, just the video, there is one channel that I'm getting, I can see everything what is going on. Even if the cellular network is failing, I will know what is going on. Maybe I'm not able to control it, but I will know what is it, how to manage it. What else? Of course, you see the final project, but there are mistakes as well. This was a system that I wanted to make. It was based on buoyancy. So you can put air, and if you have compressed air, you can uncompress it when you're under the water. So I thought that it was maybe a nice idea. So when I did it, this is it getting the, filling the bottle. I was looking for enough air so I am able to manage the ROV. What happened is that this is an inflating system for a wheel of a car, and it works, and the bottle is from paintball bottles. It doesn't get enough pressure to release more than 1, maybe 2 liters of air, and that's nothing. Under the water is almost nothing. More things. What didn't work out in the first place? My own browser. Until I met current control, I was building my own one. So that's time that you spend thinking and planning and doing and programming that didn't went anywhere. The automatic buoyancy system didn't work. It was not enough pressure, not enough with the basic materials. And I could take it to the scuba diving center, but that's not the purpose. The purpose was to make it with stuff that you can buy at home. Also, I have problems with mass distribution and volume distribution because the Archimedes is slow. Because the buoyancy, when in this shape, there is some buoyancy. The cap is closed, and there is air inside. So this is displacing already some water, and it's not going to change. So first time that I put in the water was getting, upside down, for example. So that's things that you have to work out. Insulation was another problem in the first time. In the second time, actually, water, a little water going inside, things that you have to work out. There is the umbilical is the cable. You have to find how to manage it. The system is already in the water and it's diving somewhere. You have to manage the umbilical itself. When we're in the ship, we do it by hand. We roll it in, roll it out. But this system is alone in the sea, so you have to manage it. I was working on it, didn't do it yet, but had already some ideas what the buoyancy system can do, and was an engine that is rolling it in and out. Since the cable has zero buoyancy, so it will stay wherever is in the water, and this is one thing that is good. ROV dimensions, this is too big. In general, when you see a normal ROV, they are not much smaller, the professional one, but in my opinion, this is too big. You can make it smaller, you can reduce it a lot. It will change the performance under the water as well. What else? Aerodynamics, there are edges. These edges, and especially the legs, they can stand. They can, when you are turning the ROV, the cable can get around. So if you are maybe 20, 30 meters under the water, and your ROV gets stuck in some plants and with your leg, difficulty you will get it back. So you have to pull and things like that. Propellers. The first version of propellers were some small one. I don't have it then here, but it was like the half size of this. So it was moving really slow. It was working, but really slow. So I had to change it in the way. This is a way of development that you have to try, fail, and find out a way. So what else is here? Wait, maybe. Yes, I passed one important. It was actually my Achilles, I don't know how to say, the GCM GPRS GPS module. Nobody knew around. I talked to people from my university. I talked with friends that work in electronics every day. Nobody knew how to power on a GSM module. And they need a specific power to start up. It's just exactly 2 amperes, which if you are working with microcontrollers with so small energy, if Arduino, let's say Arduino, starts and the system is booting, and in that moment, you say to the module to start, when it takes the 2 amperes, it sucks every energy that you have in the Arduino. So it reboots, it's shut down. So you have something that you built, and you don't know why it's rebooting, first thing. When you find out how to resolve it, somebody told me to use supercondensers. And this actually was the solution, but it wasn't that simple, like to use one of them. I had to use 2 in a specific shape, and it worked. In between all of this, it was like maybe 2 months with errors, trying and over. And that was actually the moment that I maybe wouldn't finish the ROV. I decided to go with it. What else? Command and Conquer. Command and Conquer is a game. It's actually divide and conquer. The approach I decided to do is I get all the information. The boy is processing the map link because Raspberry Pi Pico is faster and has more memory, and the ROV inside has Arduino. So Maplink, the Cougar control is using Maplink, and the best approach is to divide. You can send to a buoy, for example, packages in Maplink, and you can split it and use the buoy as a gateway. So you can send to the bus, you can send different packages in Maplink, and each part of the ROV should process it, not only one central unit. That will reduce my memory and will increase my speed. So that was one thing. The water analysis board is something that I had to, this is it, and I had to work on to check it out because it's already built, you can see it. And we are working with another friend. We are working in Torpedo. Torpedo is a MicroPython, it's a different approach, and we say like fast and furious. It's something that we wanted to go faster and cover bigger areas. So it's not using propellers, but it's using pumps. It's getting the water and uses it's the idea, because it's not finished, is to use water propulsion. We had to learn, and we had to try, and we had to prove. So this is it. And the idea is to analyze big areas of water. Other uses. There are more uses. I wanted to scan only the coast, but you can use it for underwater photography. If you make just change the microcontroller for something stronger, can make analysis, can have image analysis, maybe can follow you divers and can make photos of the divers. You can use it with bigger program. You can use it for body search, automatic body search. It can use for study invasions of species invasions. It happens in algae mostly. Archaeology. You just can send and look, and you don't have to take all the coast of scuba diver, which is actually pretty big. Disabled people can dive. And I'm talking about full disabled people, because I dive with disabled people and they are performing better than us. Game simulations, you can use it for racing under the water. If you have enough big, small, and fast submarines, you can make that. And this is a way of making cheap telemetry, but bathymetry is to find which is the depth on each level, so you can have a map of the depth of the sea. Conclusions. I had to learn electronics and microcontrollers. The most important thing is that, yes, I can do it, and if I can do it, you can do it. But this is the most important. The GDSM model taught me that. Never abandoned, because somehow you will find a way. So just keep going on it, keep researching. I know how to make a sonar, and I haven't gone for it, but it's crazy. And every time that you can use free hardware and free software, and share it with the world. So tomorrow we will have a Google map of the seabed. And this is Alioli. I'm sorry about the sound.
Una más de este. Otro. Y ahora los dos.